I want to talk about something that I really wish I would have known my very first day as in the HVAC career, and that is about latent heat and how it works and its relation to superheat and subcooling. Because like even in school, my instructor would tell me that latent heat is just heat goes in and heat comes out, and it doesn't change the temperature of the refrigerant, and it's just magic. He would literally say it's magic, and I was supposed to be okay with that, and I was for a little bit, but I really did some reading about it, and I found this explanation that just blew my mind really, and it makes it so easy to understand. And I just wanted to explain it and how it starts. I'm going to make a graph here, and I'm going to say this y-axis is your temperature, and the x-axis is heat applied. So as you move along this x-axis, heat is going into the system. And then if you move along this way, heat is being taken out of the system. And we're going to start with something like water, and it's going to look like that. And we're going to pretend you're in some magical vessel that keeps your pressure constant as you heat it up and cool it down, which is easy to generalize later, but for now, we'll just look at it like this. So this is all liquid water. And once it gets to a certain point, which is, in my country, 212 degrees Fahrenheit, it's going to start to boil. And when the water starts to boil, the magic that my instructor was talking about is just that it takes heat energy to boil the water. So like if you have a tiny little small amount of water and it's liquid and you add heat to it, that water will boil and turn to 212 degrees steam. So the heat that came out of the atmosphere, went into the water, changed it from 212 degree water to 212 degrees steam. It didn't change the temperature. The temperature is still 212 degrees, but heat went into it. It took heat out of the atmosphere. And the thing is, if you have a bunch of water, then it's going to take a lot of heat to turn it all to liquid. So we're going to get a line that kind of looks like this. Now, here, at this point, it's all liquid. You keep adding BTUs of heat into it, it's going to start to boil the water, but like say around right here, you have a little bit of steam, mostly water. As you keep adding heat into it, somewhere around here, you have mostly steam and a little bit of water. And then once you get to the end, like there's a point where it's all going to be steam. Once it's all steam, it's all turned into a gas, you're going to heat up. Like you can have like 300 degrees steam, as long, is like water can't, well, like the liquid water can't get hotter than 212. Once it's all steam and you keep adding heat, it'll get hotter. This is all going to be gas. And then this flat line, this whole flat line where it's changing state, this is what we call saturation. So if we're not talking about water anymore, we're going to talk about R22 or any refrigerant. And it's going to start in a compressor. So this is your compressor, this is your metering device. It's going to come out of the compressor, it's going to go through a condenser to the metering device. It's going to come out of the metering device, go through an evaporator, and back into the compressor. So when it comes out of the compressor, it's a hot gas. So like liquid can't go through the compressor, so it's a hot gas coming out, and then it goes into the condenser, and it's going to be its point on this line is going to be somewhere around there. Now, once it goes into the condenser, it's going to be super hot, and even if there's like 80 degree air outside, that 80 degree air is going to be a lot cooler than the refrigerant going through the condenser, so the 80 degree air is going to pull heat out. Like that refrigerant's going to heat the air up, heat is going to move out of the system into the air of your condenser and be blown away. And so as it goes through the condenser, you're going to be moving down this saturation line. It's all going to be staying the same temperature, but as heat's being taken out, it's going to be more and more liquid. So it's going to start the gas coming out of the compressor. It's going to condense to a liquid, condense to a liquid. Heat is actually leaving the system. It's staying the same temperature, but it's turning into a liquid. That's where the heat's going. The heat's turning it into a liquid. And then once it gets to a point where it's all liquid, and that's going to be hopefully somewhere in this kind of area of the condenser, it's going to be all liquid, and you still have a little bit of condenser left. There's still air going over it and taking heat away. It's going to go from this point here and down and maybe settle here. So once it's out of the condenser and goes to the metering device, it's going to be all liquid and then cooled just a little bit. And this little bit right here, this is your subcooling. So it's going to be like the subcooling is just how many degrees difference it is below saturation. So then it's going to go through this metering device. And when it goes through the metering device, it's going to be changed to a low pressure super quick. It's going to get a lot colder. And that's where this generalization of your, it's not the same pressure through the whole thing. The point is, though, when it goes through the metering device, no heat, no actual heat was, BTUs were added in or taken out. So it's going to get a lot colder, but the pressure is going to be a lot less. You're still going to be at this point down here. It's still going to be a liquid, and it's still going to be a little bit subcooled. So once it starts going through the evaporator, it's going to spray out as tiny little droplets of water, which very quickly turn to gas because the air going over it is a lot warmer than the gas. So heat from the air is going to be added going into the evaporator and into this refrigerant. So this line's going to start coming up. And so as it goes to the evaporator, you're going to be moving up this saturation line. You're going to be moving up. And so somewhere near the end of the evaporator, maybe around here, you're going to be all gas. And then there's still a little bit more evaporator left. It's still going to be taking heat and putting it into the system. It's going to heat it up to somewhere around here. And this little area here, that's your superheat. And then it's going to go into the compressor, and it's going to get compressed. Same thing here. It's going to get compressed, and it's going to be a lot hotter, but no BTUs were added or taken away. So it's going to stay at this point on the line, and then the whole cycle continues. And I guess the whole point of this is just to realize that's where this is all the latent heat. When the dot starts here and it moves up this line, it's not changing temperature, but heat is going into the system. Heat is being taken out of the atmosphere and put into the system, and it's not getting warmer, it's changing the state. As it goes backwards, heat is being taken, as it's in the condenser, heat is being taken out of the refrigerant and put into the air, and warm air comes out, but the refrigeration does not change temperature. It's just changing from a gas to a liquid. And that whole concept that it takes energy to change from a gas to a liquid and vice versa, that is latent heat. That's how you can add heat to the system or take heat out of the system and not change the temperature. And hopefully that just blew your mind, because it definitely blew my mind, and it made so much sense. And I would have gotten a bunch more test questions right if I knew exactly how that worked. So hopefully you got something out of that. So thanks for watching.